Hi everybody, it's Professor Mitchell. Today we're talking about section 1.9, distance and midpoint formula and circles. We will do a little bit more with this section when we get to pre-calc. We are going to do most of it now though. This goes with assignments 8 and 9. As you know, assignment 8 is to watch this video, assignment 9 is the homework. So we are going to cover the distance formula, which is how you find the distance between 2 points, finding the midpoint of a line segment using the midpoint formula. Then we're going to get into circles. And the only thing with circles that I don't plan to do in the trigonometry class is this last thing at the bottom. We'll do that when we get to pre-calc. Okay. So I don't like to just come right out and tell you what the distance formula says. I think if you have some understanding of where it comes from, it makes it easier to remember. So let's say that I have 2 points, -1, -3, and 5, 5. So the first question I'm asking is, what is the distance between those 2 points? So I have drawn a line. Let me pull up my spotlight here. So here's the point -1, -3. Up here is the point 5, 5. So I want to measure the distance between these 2 points going directly across this line. Okay. And then let me see if I can remember how I set this up. Okay. So these 2 line segments that just appeared, I've got a horizontal line going across the bottom, and I've got a vertical line going up here. I'm sorry it doesn't align perfectly with my grid. But the reason I did that is because I'm actually going to use the Pythagorean theorem to calculate this length. And I have not written a lot of the details in the PowerPoint, but for example, from here to here along the bottom, that would be a distance of 6, right? Because we're going from -1 to 5. So to find that distance along the bottom, you would just do 5 minus -1, okay? And then you would do the same sort of thing going from the bottom to the top. Down here, I am at -3 using the y coordinate. Up here, I'm at 5, so that would be a distance of 8, right? From -3 to 5. 5 minus -3 is 8. All right, so I'm going to throw caution to the wind and try to use the pen again. Okay, so what I'm saying is the length of this line segment is 6, which came from 5 minus -1. And the length of this line segment is 8, which came from 5 minus -3. Excuse me. Okay. All right. So I think what I would like to do now, okay, so then that means if I wanted to measure the distance of, or the length of, let's call this d, I could just solve the equation d squared equals 6 squared plus 8 squared. That's the Pythagorean theorem. And by the way, there is a formula coming up, so you won't have to do all of this every single time. Okay. In fact, I think what I'd like to do now is skip ahead to the formula. So let me clear my scribble here. And it does talk about the midpoint formula. I'm going to do that. I think I'll come back and do that later. Okay. All right, so this is your distance formula, and it does come from the Pythagorean theorem. So right here, where you find the difference between the x's, that was like when I did the 5 minus -1. If you drew a triangle like the one I had on the last slide, this would be the length of the bottom piece, one of the legs of the right triangle. And then this difference here would be the other leg, which is the vertical side, okay? So you find those differences, you square them, add them together, all right? And then to find d, as opposed to d squared, you would take the square root of this thing. Okay. So you can probably ignore this paragraph right here. They're thinking that if they say the formula in words, that might be helpful to some people. I don't know who those people are in this case. Sometimes formulas are easier to remember in words. I don't know that that's the case with this formula. Okay, so let's do an example now that we know the distance formula. If I can get this to work. There we go. So they want me to find the distance between the points -1, -3, and 2, 3. And they want me to write the answer in two different ways. First by writing it as a simplified radical, and then by using the calculator and rounding it to 2 decimal places. Okay. So remember, the formula is d equals the square root of the difference in the x's squared plus the difference in the y squared. So I'm going to plug all those things in. And what I always recommend, anytime you're working with a formula that's got y1, y2, x1, x2, it's very helpful to actually label which one is x1, y1, and which one is x2, y2. That way you don't accidentally put the numbers in the wrong place. Okay, that is a very sorry looking 2 right there. Okay, yeah, I know it looks more like an L. Okay, that looks a little more like a 2. Okay, so now, after I plug those numbers in, I get the square of 2 minus -1 plus the square of 3 minus -3. And then, of course, 2 minus -1 is 3, and 3 minus -3 is 6. Okay. 3 squared is 9, 6 squared is 36, so I do 9 plus 36 is 45. Now, you may be a little rusty on how this next part works. In order to simplify that radical, the square root of 45 is not in simplest form. And the way you put it in simplest form is first ask yourself, is it a perfect square? All right, if it's a perfect square, that's like the best thing that can happen. 45 is not a perfect square, so the second best thing is, does it have any perfect square factors? 45 does have a factor 9, which is a perfect square. So then you can break this radical up into 2 separate radicals. The square root of 9 is 3. The square root of 5 is just the square root of 5. So the exact simplified answer for the distance from -1, -3 to 2, 3 would be 3 times the square root of 5. And the approximate answer that you would get from your calculator is 6.71. All right, so now let's start looking at the midpoint formula. So the second question is, what is the midpoint of this line segment that connects -1, -3 to 5, 5? This one I think is pretty intuitive. What this says is, to find the midpoint of that line, you just average your x coordinates. So let me get sort of a rough idea of where that would be. I would say halfway between here and here would be what, maybe here? Okay. And halfway from here to here would be about here. Okay, so my guess for the midpoint would be right about there. Okay. All right, so and it turns out that's exactly what the midpoint formula says. Okay, so let's get rid of that. We'll skip over to midpoint formula. Already did that, already did that. Okay, so yeah, the midpoint formula says in order to find the midpoint between 2 points, you just average the x's and average the y's. And this would be a situation where I do think that putting the formula in words is actually very helpful. All right. I think it's much easier to remember if you think of it as average the x's, average the y's. Okay. So let's look at an example of that. So they want me to find the midpoint of the line segment whose endpoints are 1, 2, and 7, -3. So again, I would suggest that it might be a good idea to label which point is x1, y1, and which point is x2, y2. Okay, those twos look a little better. All right, so there's the formula. I'm replacing x1 with 1, x2 with 7, and then y1 with 2, y2 with -3. 1 plus 7 is 8. 8 divided by 2 is 4. 2 plus -3 is -1, and -1 divided by 2 is just -1/2. And that's the midpoint formula. Okay, and that brings us to circles. So of course, a circle, I mean, you might not think of it this way every day, but a good sort of mathematical definition of a circle is the set of all points that are equidistant, same distance, from a fixed point called the center. So for example, you have a point at, well, the example I'm going to use is 2, 3. The set of all points that are 5 units away from the point 2, 3 would form a circle. Okay. So the main thing we're doing in this section, and that distance, that fixed distance, is called the radius of the circle, right? So the main thing that we're doing in this section is we are looking at the equations of circles. You know, if I handed you an equation and said graph this, the graph would come out to be a circle. Okay, and again, I don't like to just come right out and tell you what that formula is. I like to have it make sense to you. And so the way I always do that is I say, okay, suppose that you have a circle whose center is 2, 3, and whose radius is 5. Okay, what would be the equation of that circle? Well, let me take some mystery point on the circle. And again, this is one of those things we're only going to do it this way one time. And after that, we'll have a formula. If x comma y is any point on the circle, then it must be true that the square root of x minus 2 squared plus y minus 3 squared would be 5. Take a second to think about why that is. And where did I get that from? That comes from the distance formula, right? It's saying that the distance from the point 2, 3 to the mystery point x comma y is 5. Okay, that's why we always talk about the distance formula before we talk about circles. Every single math book, you know, algebra, pre-calc, you'll always notice that the distance formula comes right before they talk about circles. Okay? So now we can clean up this equation a little bit by squaring both sides. And when you square both sides, what you get is no more square root. X minus 2 squared plus y minus 3 squared must be 25, right? If the square root of all that stuff is 5, then that stuff without the square root must be 25. Okay, so let's look at an example. Oh, actually, well, let's look at the formula first. All right, so this is called the standard form of the equation of a circle with center HK and radius R. And that is the standard form of that equation. X minus h squared plus y minus k squared equals r squared. All right, so if they hand you the center and the radius of a circle and they ask you to write the equation, that's very, very easy to do. You just have to be careful and remember that this formula has a couple of minus signs built into it. Okay. All right. So I think the example is coming up now. Here's the example. They want me to write the standard form of the equation of the circle with center 0, -6, and radius 10. Okay. So I'm going to take my formula, which is x minus h squared plus y minus k squared equals r squared. And I'm going to put in the h and put in the k and put in the r. And of course, let's see. This thing here is h, this is k, and this is r. Okay. So here's what you get when you do that. X minus 0 squared, because h is 0. Y minus -6, that's why you have to be careful with that built-in minus sign. Y minus -6 squared equals 10 squared. So then the only thing that they'll, expect you to do after that is just pretty it up a little bit. So after you pretty it up, you rewrite x minus 0 as x. You rewrite y minus -6 as y plus 6. And 10 squared is 100. So that is the standard form of the equation of that circle. All right, so the last example with circles, this is the backwards version of the example we just did. Now they're giving me the equation of the circle and asking for the center and the radius. So this is where you have to be super careful about remembering that the formula has some built-in minus signs. Okay, I'm going to show a little bit more work there. I couldn't remember what I had built into this. So the reason the center is -3, 1 is because, remember, you have to think of this as x minus h. Because of the built-in minus sign, I'm going to think of that x plus 3 as x minus -3. Sorry about the horrible looking 3. This one already has the built-in minus sign. We call that number k. So because the minus sign is already there, that means that k is 1. So k is 1. H is -3, okay? And then the other thing you have to be careful about is the radius. Some people want to say the radius is 4, but remember, this number over here is not r, that is actually r squared. So since r squared is 4, that means r is 2. So that's why the radius is 2.